Well, hello everyone. This is Mehul Anand from Section B, and today I'm going to give you an introduction to FETs or field effect transistors. Field effect transistors are a three-terminal device as we can see in this figure, where the points D, G, and S represent three things, where D is the drain, G stands for gate, and S stands for source. The voltage difference between the points G and S, or the gate and the source, is known as VGS, and where ID represents the output current. FETs and BJTs are similar in their applications. BJT is a topic we have studied in our last module, and some of its applications, or the sum of applications of FETs, are as amplifiers. FETs are used as amplifiers for an audio and for radio frequency, etc. And FETs are also used as mixer circuits, which are used to reduce low intermodulation distortion. FETs are a voltage control device, as the current ID we have seen above depends upon the voltage VGS. Thus ID is a function of VGS and can be said that it is controlled by a parameter of input circuit. FET is a unipolar device because it solely depends either on the electrons or on the holes present. FETs can be classified into two types, which are N-channel and P-channel. N-channel is very similar to the NPN type transistors, and P-channel is similar to the PNP type transistors. N-channels, or which is similar to NPN transistors, depends on the electrons present, whereas P-channel depends on the holes present in it. FETs can be classified into two types, mainly being JFET and MOSFET, where MOSFET stands for metal oxide semiconductor field effect transistors. JFET can be further classified into two types, being N-channel and P-channel, whereas MOSFET can be classified into two types, being DMOSFET and eMOSFET. DMOSFET can also be classified into two types, being N-channel and P-channel. And eMOSFET can also be classified into two types, being the same, N-channel and P-channel. This was the classification of field effect transistors. And in field effect transistors, electric field is developed due to the charges present or due to the electrons and holes present in it. And the electric field controls the conduction path of the output circuit, which describes the field effect in its name. And for the last, there are some points about FETs, field effect transistors. Field effect transistors have high input impedance in comparison to BJTs or bipolar junction transistors. They are more stable, more temperature stable than bipolar junction transistors, smaller in size than bipolar junction transistors. But bipolar junction transistors have one thing greater than field effect transistors, that bipolar junction transistors are more sensitive to applied signals. So my friends, this was a short introduction to field effect transistors, and I have explained to you basically the types of field effect transistors and some of its applications, and the classifications of field effect transistors and its comparison with bipolar junction transistors. So this is all for this introduction, and please do like the video. Thank you everyone.